You can see now that the temperature is at -7 degrees, so we've still got 3 degrees Celsius to drop, 2.5, 2. It's only taken about 5 minutes, to be honest with you, but okay, so it got to -9 and decided that was cold enough, so it would start. So this is the plate solving. So it will take an image now of where the telescope is pointing. And now it will send that image off to a database and it'll try and plate solve it. So it says, yeah, telescope not inside tolerance, re-slewing to target. So it said, yep, we agree that this is not where it should be pointing. We're going to repoint it to a better spot and see where we look now. And this is the next image that it took. And it's currently trying to autofocus now. The focusing should be pretty good. So that is Orion's Nebula. So it has taken the image. This image will get out of focus now as it moves the focuser in and out to try and identify the perfect focus. So what it's doing here is, this is the position where it started. It started at position 79,000. Sorry, this is where it started. It started off at 80,000. And then it took another image at a focus range of 79,800. And then another one at 79,600. And what you'll see over time, this will become an arc that'll do this. So it'll, as it starts getting great focus, it'll start swinging up. And it'll get worse and worse and worse, and that way you can identify at the lowest point what the perfect focus range should be. And you need to do this between each filter wheel change, because focus changes dependency on the amount of light that comes through, and the red, green, and blue filters will all be consistent, but the hydrogen, alpha, oxygen, and sulfur, each one of those they restrict a huge amount of light coming in. So the focus will change for each one of those. The focus point will. You can see it's already swinging upwards, so this will be more or less the perfect focus point. And once it's identified that point, it'll actually move the focuser back to the perfect position so that you're all good to go. You'll see some crazy things like this from time to time. I'm not really sure why. It says, negative 127 degrees Celsius. Like, if that was the case, we'd have a totally different set of problems. But as I said to you, this software is all put together by different operators, so it becomes a little bit difficult. So it's actually now taking the images that we asked it to take. Remember, we said it was going to take 2 images of 30 seconds long. And so it's almost 25 seconds into the first image. And once it's taken that, it'll display it over here. And you'll actually see that a 30-second image will show a lot more clarity. And now it's actually going to take the second one. And then we will have had 2 images completed. So this is the image that's up and running of this. And you can, I'll show you where we go and look for this in a moment, the actual physical image where it's being recorded. This is actually just a preview of it. But I mean, you can zoom in and do some basic stuff at this point in time. The resolution here is really bad because it's a remote computer connected to another computer, and the connection isn't great, so it's going to be a little bit different. So once it's finished this image, we're going to go back to the framing, or back to the sequencer rather, and we're going to take one image and we'll try and take that image over a longer period of time, and you'll see the difference in terms of the quality of the image that comes through. Okay, so It's going to now park the telescope. It'll send the telescope back to its original position, its starting position, and prepare it to effectively be done for the night. So whilst it's doing that, we're just going to go to the sequencer, and we're going to modify that exact same sequence. Sorry, it can be real slow sometimes. Okay, so what we'll do now is we're going to modify this sequence. We're going to call it, let's say for example, we're going to say we want, we're going to make this 4, but instead of taking them 30 seconds, we'll take them for 60 seconds. Okay, and all the parameters should remain the same. Might make this 5 because it's already completed 3, so we'll make it 5, and we'll hit play again, and it's going to go through the same process again. It'll slew, it'll plate solve, it'll autofocus, and that's only because I set it up as a very brief one-off shot. You can set up multiple of these. So for example, if you wanted to do a night's worth of imaging, you would just effectively create another sequence and another sequence and another sequence. And let's say you wanted to do LRGB, you could sit and say, okay, I want 150 60-second images of L, then 150 60-second images of R, and so on and so forth. And it will just continue through each one of those without interruption. We're not going to do that, obviously. So once it's done these 2 images, I will then go and show you the images that we've just captured. And it's just going to go through the autofocus process again. I know this probably sounds very complicated, and it is, but the more you do it and the more problems you experience, the more you'll be able to problem solve them, and it'll get easier and easier over time. And it genuinely does become easier. So the nice thing about this though is, of course, that you can set it up on the computer outside, and then hopefully you've got a computer at home that you can use to connect to it, and then you can, from your bedroom, sit and monitor and manage what's going on. And once it's operating nicely, you can realistically just set it and let it run for however long it wants to, and you don't need to sit and watch over it. I see that there's actually an update available for the software. I'm not going to do it right now, but I will update all the software before I send it over to you, so you've got the latest versions of everything, just so that I can at least test them before I send it over to you. What you're looking for with focus is something called HFR, half flux radius, and the lower that number is, the better. The lower that number means that that ultimately your focus is really sharp. So that's what you're aiming for. I'm not going to worry too much right now about this warning on the side here called dither. That's only because we're not doing guiding at this point in time. I'm going to refer you to a tutorial rather than try and walk you through that as well. Okay, so now it's busy capturing. You'll see at the bottom here, it's capturing another image, but this one is now going to be at 60 seconds long. So it'll take 2 of those, and then I'll pause this and I'll open those 4 images for you, and you'll be able to see what they look like. So automatically, just on the preview, you will have seen a significant increase in lightness. So that's good. The more light it gathers, the better. And in actual fact, I think if you look carefully here where my mouse is moving, there looks like a star trail. That's actually not a star trail, it's probably a satellite. And that's something you'll have to get used to. The sky is littered with satellites. And it's kind of exciting when you first start seeing them, but they actually just ruin your images over time. So you'll find that if you took, let's say for example, you took 500 or 600 images over the course of a night, you'll probably lose, I don't know, 50 to 60 of those images because of satellites going through them. Okay, we've only got like 5 more seconds of the next image, and then I'll start another video and we can talk through what those images look like. Okay, so that's the second one then.